In the early 1970s, a young geologist from Lemont Dorothy Lab at Columbia University was doing some fieldwork in Italy near the Umbrian hill town of Gubbio, halfway between Rome and Florence, where he grew interested in a thin band of reddish clay, barely a quarter-inch thick, that divided two ancient layers of limestone, one from Cretaceous period and other from Tertiary. This point of time in geology is known as KT boundary, marking the time of 65 million years when dinosaurs and roughly half the world's other species of animals abruptly vanished from the face of Earth. Now, the geologist wondered if this quarter inch thick clay could account for extinction of one of the largest living creatures on the planet Earth. Normally, this geologist could have left this problem then and there, but he had an important connection to someone outside his field, which was his father, who was not too happy with his son's attachment to rocks, but this problem intrigued him. It occurred to him that the answer to this might lie in space from dust. Now, this is very important. Every year, the Earth accumulates about 30 metric tons of space dust, and among this dust is the element iridium, which is 1,000 times more abundant in space than on the crust of this planet because it is thought that most of the iridium sank to the core when the Earth was pretty young. His father knew colleagues at Lawrence Berkeley Laboratory who had developed a technique to measure the chemical composition of clay called neutron activation analysis, which involved bombarding samples in a small nuclear reactor and counting the emitted gamma rays. In October 1977, the father and son duo went to the scientists to know if they could run the required test for them, to which they agreed. The testing was completed in June 1978, and the results were so unexpected that the scientists thought that they had to be wrong since the amount of iridium in the samples was over 300 times the normal levels. Later, the testing was done on samples from Denmark, Spain, New Zealand, and many other places, showing elevated levels of iridium everywhere, sometimes as much as 500 times more than the normal levels, clarifying that something big and abrupt had happened. After much consideration, they reached a conclusion, or at least a conclusion plausible to them, that Earth had been hit by an asteroid or a comet. When the announcement about this was made at the American Association for Advancement of Sciences that the dinosaur extinction had not taken place slowly over the time of millions of years, but suddenly in a single explosive event, it shouldn't have come as a shock, but it did, especially in the paleontological community, referring it to as an outrageous hearsay. Since these scientists, who were not paleontologists, had solved a problem that had eluded their community for over a century. And the fun fact about the story is that discovery was not made by a paleontologist, but by a geologist